From our quiet corner of the cosmos, the universe can seem distant, serene, a grand, silent spectacle. You'd be forgiven for thinking we're immune to the real chaos going on up there. But out in the deep past, cosmic engines were roaring to life with an intensity that almost beggars belief. And now, thanks to a discovery that was hiding in plain sight, we've found the new champion. Astronomers have just confirmed the most luminous quasar ever found, a beacon powered by a supermassive black hole so voracious it swallows the equivalent of an entire sun every single day. This isn't a theoretical model, it's a real object, a monster from the dawn of time, and it's forcing us to rethink the limits of what's possible in our universe. What you're about to see is a cosmic powerhouse that almost defies the imagination. Astronomers have just pulled back the curtain on something truly record-breaking. What they found has been given the rather unpoetic name of quasar J05294351. It lies in the constellation Pictor, so far away that the light we are seeing from it tonight began its journey across the cosmos over 12 billion years ago. This means we are looking at a relic from the early universe, a glimpse into a time when the cosmos was just a toddler, less than 2 billion years old. The discovery, announced by a team at the Australian National University and confirmed using the European Southern Observatory's Very Large Telescope in Chile, has sent a wave of excitement through the scientific community. For years, we have known about quasars, these intensely bright cores of distant galaxies powered by supermassive black holes. But this one is in a class of its own. It is so bright, so massive, and growing so fast that it stands alone. By every measure we have, it is the most luminous, persistent source of light in the known universe. But to truly grasp what that means, we need to look under the hood and see what's driving this thing. So before we go any further, what is a quasar? The name is a bit of a historical leftover, short for quasi-stellar object, because when they were first discovered, they just looked like simple nearby stars, but they couldn't be more different. Think of a quasar less as an object and more as an event, the spectacular, violent result of a supermassive black hole at the center of a galaxy going on an absolute feeding frenzy. At the heart of J05294351 is a true monster, a gravitational titan weighing in at an estimated 17 billion times the mass of our own sun. Imagine 17 billion of our stars crushed down into a single point. But it's the black hole's appetite that's truly staggering. We believe it's the fastest growing supermassive black hole yet found, devouring matter at a rate equivalent to one sun's worth of material every single day. Now, when a black hole eats, the matter doesn't just politely fall in and vanish. Instead, it gets caught in an immense gravitational grip and is whipped into a vast, swirling vortex of shredded stars, gas, and dust. This is called an accretion disk. For J0529-4351, this disk is the largest ever found, measuring a mind-boggling 7 light-years across. To put that in perspective, a trip from one side of this disk to the other would take 7 years traveling at the speed of light. As all of this material spirals inward at incredible speeds, friction and intense gravitational forces heat it to unimaginable temperatures. We're talking tens of millions of degrees. And it's this superheated, glowing disk of matter, not the black hole itself, that is radiating an unimaginable amount of energy, burning with the intensity of 500 trillion suns. This is the beacon ignited by gravity itself. A luminosity of 500 trillion suns is a number so vast it's almost meaningless. So let's try to put it in perspective. Imagine our sun, the star that gives life to our entire planet, is a single grain of sand. At that scale, the light pouring from quasar J05294351 would be a shining sphere of sand the size of a professional sports stadium. Let's think bigger. Our Milky Way galaxy is home to hundreds of billions of stars. If you could somehow gather all the light from every single one of those stars into one point, it would still be hundreds of times dimmer than this one quasar. This single object is outshining an entire galaxy of stars. Here's one more way to think about it. J05294351 is over 12 billion light-years away, appearing in our best telescopes as just a faint dot. But if you could magically transport this quasar to the center of our own Milky Way, about 26,000 light-years from us, it would completely change our reality. It would shine so brightly that it would erase the night. The sky would be lit in a permanent, bright twilight, and the quasar itself would be the brightest object in the sky by far, casting noticeable shadows on the ground. This incredible brightness is a testament to the sheer violence of its central engine. This black hole is feeding so ferociously that it's pushing right up against a theoretical threshold known as the Eddington limit. That's the point where the outward pressure from all this light should, in theory, become so intense that it literally blows away its own food supply. This quasar isn't just running at full throttle, it's hovering at the red line, operating at the very edge of what we thought was possible for stable accretion. It's discoveries like this that remind us just how much of the universe is still waiting to be found. If you want to keep exploring these cosmic frontiers and stay updated on the most mind-bending discoveries in astronomy, make sure you subscribe and ring that notification bell. You won't want to miss where we're going next. But perhaps the most incredible part of this story isn't just what was found, but how it was found. Because this cosmic titan wasn't in some unexplored corner of the sky. It had been staring us in the face for 40 years, hiding in plain sight. The object was first recorded on photographic plates from a sky survey way back in 1980, logged as just another data point among billions. So why did we miss it for so long? The answer is almost poetic. It was simply too bright. In the modern era of astronomy, we rely on automated programs and machine learning models to sift through the mountains of data from sky surveys like the European Space Agency's Gaia satellite. When the Gaia algorithm analyzed this spot in the sky, it saw an object so luminous it concluded it couldn't possibly be a distant quasar. Nothing that far away could be that bright. The algorithm decided the most logical explanation was a common, nearby star, and flagged it as such with over 99% confidence. The most luminous quasar in the universe was dismissed as just another uninteresting data point. It took the keen eye of human astronomers in 2023 to give it a second look. Using a telescope at the Siding Spring Observatory in Australia, they suspected it might be something more. But to confirm its true nature, they pointed one of the most powerful instruments in the world at it, the X-Shooter spectrograph on the Very Large Telescope in Chile. By splitting the object's light into its component colors, its spectrum, they could read the chemical fingerprints of the material in its accretion disk and, crucially, measure its redshift. The extreme redshift they found confirmed its immense distance of 12 billion light-years. And with that distance finally known, its true, mind-shattering luminosity was revealed. As one of the scientists on the Discovery team put it, it has literally been staring us in the face until now. So, finding a new, brightest quasar is more than just an entry in the cosmic record books. Discoveries like this are fundamentally important because they act as a unique laboratory for testing our ideas about the universe, especially the early universe. Because its light has traveled for 12 billion years, we are seeing this quasar as it was when the cosmos was in its infancy. One of the biggest puzzles in cosmology is how supermassive black holes got so big, so fast after the Big Bang. Our current models struggle to explain how a black hole could reach 17 billion solar masses in less than 2 billion years. J05294351 is an outlier, a cosmic case study that pushes our theories to their breaking point, forcing us to ask if we're missing a piece of the puzzle. It helps us tackle the cosmic chicken and the egg problem. Which came first, the supermassive black holes or the galaxies that host them? By studying an object where the central engine is growing at such a furious pace, we can gather clues about the relationship between black hole growth and galaxy evolution in the universe's formative years. And beyond that, this quasar provides a real-world test for the physics of accretion at the most extreme limits imaginable. How does a black hole sustain a diet equivalent to a sun a day without blowing itself apart? How does an accretion disk stay stable when it's 7 light-years wide? Answering these questions won't just tell us about quasars, it will deepen our understanding of gravity and radiation pressure under conditions we could never hope to create on Earth. The story of J05294351, from a misidentified dot on a 40-year-old photographic plate to its coronation as the king of quasars, is a perfect reminder of how science works. It's a process of data, human curiosity, and that vital second look. We have found a monster powered by a gravitational engine of unimaginable ferocity, shining from the dawn of time. It's an object that challenges our sense of scale and pushes the boundaries of our physical theories. And the most exciting part? It was waiting for us, hidden in our own archives. It leaves us with a profound and humbling question. In the endless ocean of cosmic data we have yet to fully explore, what other impossible wonders are still out there, just waiting to be discovered? What do you think is the next great cosmic mystery we'll uncover? Let us know your thoughts in the comments below. Thanks for watching, and never stop looking up.